Hey, Steve with Trimble, and for this FieldLink tip number 15, we're going to show you how to inspect cores to make sure they're within ACI tolerances. We're going to do this in FieldLink for some infield deliverables like you see below, as well as in RealWorks. We can do some more precise and a little more detailed deliverables. So, um, again, we'll talk a little bit about collection here, but we actually already have the data. We'll then actually talk about registration and georeferencing, which is pretty important, and then show you how to do those inspections and then what to export. If you're going to Navisworks or Revit or CAD, how to go directly to those programs or just go into RealWorks. As you can see for the collection, something like you see above in the top image, a cantilever, a boom lift is great. You can't just scan at every opening, but then you have to scan about every other or every core to make sure the registration happens. If you can get something that'll lift out in the middle and flip upside down, your registration should be a lot better because you'll have a lot better overlap. And then we'll go into RealWorks, kind of talk to you about how to import, doing a registration check, and then we'll do a wall analysis and actually an inspection before we do a bit of modeling on like the embeds if you want to actually model what's there. So here is just a list of ACI tolerances from their PDF. Again, your structural engineer should really be giving this information on what's okay and what's not. But generally, once you're, if you're underneath 80 feet or 83 feet, you got about 2 inches plus or minus 1 inch of play there. As you go up higher, it's 0.1% of that height above with a max of 6 inches of lean. What the scanner is going to allow you to do is essentially say really quickly if you're within that. If you're underneath 83 feet, you better hope you are, but this will tell you where you're going to need to grind if you're not. As you go up farther too, you're going to be able to essentially lock that in. As you do a massive elevator core, it is good to actually tie the scans back into control rather than essentially letting this kind of traverse its way up. So this is a fairly small one where the registration was good and tying in is fairly easy, but collection and tying into control with checkpoints is always recommended. The scanner can be used for essentially checking all of these. It would be just like a total station per point. But the advantage is you can tie those scans together. So the registration should be a lot closer than using control that is dropped in very tight areas. You're gonna be able to check rough openings, deformation, pre and post tension on PP decks, shoring if that's going to be needed, camber on steel, and pre and post pour. So the scanner really has a ton of use cases, and because you're capturing everything there, you're going to essentially know where things are at pretty quickly. The X7 and X9 laser scanners are going to self-level to 3 seconds, so that's why they're really ideal for checking anything with tolerance, and then the registration should be very good within that. FieldLink is going to allow you to georeference it, which just makes communication and kind of back-end work a lot easier too. So you can do that in the field, or you can do it when you export it, it'll actually stay in the right spot. So moving in to FieldLink, here is actually a couple scans that were collected. You can see this is a large building kind of turned in. So here you can see in that big model, they're actually aligned to just that south core where they're at. Plenty of other scans were actually collected for this. And if we actually turn these other ones on, you can see what the full core looks like. I'm using a couple different buttons here to turn scans on and off, and then the section box really makes it really easy to tie in. So in collection, going every floor is going to really ensure that you're tying in correctly. Again, a low level scan with the X9, if you take images, it's going to be 2.5 minutes or 1.5 minutes to collect. So these, what do we got here? 5, 10, 11 scans should be ideally done in half an hour. Obviously, moving it and setting it up is probably going to take closer to an hour. Coming back here, let's turn off the north wall. We can tie these together, but I really just want to look at one wall at a time when I'm doing this analysis. So here you can see scan 3s at the bottom going all the way up. Um, Generally, you can always do this post-processing, which is what I do later when I get back to the office. And what that's going to allow me to do is make sure you actually delete these so I can move it. Um, After I run an inspection, or after you run an inspection, it'll actually tie the scans and kind of lock them into place because you've done an analysis. So for this demo, I want to show you guys how to essentially tie them into the right spot. So here's scan 3. One thing I can do to align it is use a section box near the area. I'm going to use as kind of like my control, which would be right near the opening. I can then come over here and let me do one more thing, which is turn off the rest of these scans so I don't get any spray noise. I'll use the button on the bottom left to change the center of rotation. And then here you can see those points where I can essentially start to align them very precisely. So if I don't have control to tie in those scans, I'm going to align this side kind of as a visual representation. I'll then run through and actually do an inspection to make sure my alignment down here was good. You can actually see where the scans kind of bump out where some concrete got lost. But by aligning it very precisely on this side, I can also use a mouse with the zoom wheel to set my azimuth of that scan. So here you can see they actually poured the concrete quite a bit wider than was designed, about an inch. You can actually take that measurement. But I'm just doing a back wall kind of analysis to see if it lanes. I can then do south wall is what I'll do, but I can do the openings and then the east and west walls of that to make sure that they're within it. So I've aligned it on the X and Y for that scan. I can also look at it from a side view to see where the opening's at here to make sure that fits, which it does, and I did that earlier. But by moving that kind of parent scan, which is starred here, the rest of the scans going up are going to tie in. So you're going to see those when we switch to this side view. So going up, they're registering together well. A lot of times what I like to do is actually view it like this to see everything's popping in together. When collecting scans or afterwards when post-processing, I do like to register in the in FieldLink before I go to Realworks, just because it'll keep it clearer. So as collecting it, if you can keep them close, it'll essentially align a lot easier. When you're doing a elevator core though, obviously you want to get the XY, but you do want to pop from a side view and then register. And you have a couple different tools. You can put it close and register and hope that 9 and 8 have enough overlap, vertical surfaces and the floors align. But every once in a while, what will happen is the 9 will essentially think it's where 8 is because there's just not great overlap if you don't flip it upside down. So you can do a split view. Now, that one did align fairly well. We'll see. We'll actually bump it back out to see it actually up there. Yeah, it did align it well. But if it didn't, one of the other tools we can use is a split view. And that'll allow me to, here's from scan 9, here's from scan 8, see corresponding points that are close. I'm going to select here, and then find something over here too. So we'll probably say that's right about there. And so what this tool will do is essentially give it a better starting point for registration. I do want to visually check with that section box, and if I'm not confident, I'm going to check in RealWorks again too. But here I'm pretty confident. Now, what is nice is if we look at, I believe it's scan 13, we'll actually come back here. Yeah, no, it's scan 14. And we can look in here. What scan 14 did, and I would highly recommend this for elevator core or scan 13, well, scan 13, is doing an upside down scan is going to just really tighten it up. Obviously, it's going to see the bottom, so I'm going to know as these tie together that the elevation registration is going together very nicely. So if you can, every 3 floors or so, doing an upside down scan and a right side up scan will really create a tight registration. So that scan will be collected. Registration is going to work the same. You can see scan 13. 14 probably ties to 13 because they're next to each other, and 13 can see down to where 9 is and even the floor it's on. So doing that, registration looks the same. You just have more overlap. Oh, wait, was it 13? Was it 14? We'll go back one. We'll actually click back into 13. Yeah, it was 13. I guess it's just a little bit. So I could click here would be where I can match these together and do that same registration, or use even the flat side of this to start to register. So here is 1, 2. So that would be right about here. I could match these points and do the same registration matching. So there, and then I try and do non-parallel walls in points when you're registering and matching that. So that upside down scan is key for a good registration. Now, before going to RealWorks or even doing a analysis in the field, I'm going to check. Actually, before we jump in that, check the registration and make sure visually everything's lining up well. Doing this with the section box, I can look at the back wall. Oh, if I can hit it right, and turn off the model just because it's not needed for this portion to make sure everything's lining up together nicely, meaning visually there is no kind of bump out. I would look at various different widths and cuts from this. Bring this down a little bit, and I can see that's a fairly tight registration going all the way up, but I'd probably look at this for floors. If it was a misregistration, you would see one of those clouds being bumped out or rotated. So that looks good to me. I would then go to refine. And after it refines, which actually took not too much time, you're going to see it's going to refine everything that's there, but then I'm going to look at the south wall scans that I'm actually looking at to make sure that refinement is good, the overlap is good. Now, what I can do in the field, I can go ahead and actually come back here, turn this back on, south core. Is that the right one? Yeah. Let me turn off the model so I can do this and then expand it just a bit. So what I'm doing here is just essentially making this a little bit bigger to see. So here are my points. My refinement was less than a mil. I could actually just bump in here and start taking measurements. I generally will take offset measurements. I know like my X is this 19 feet in between. My Z is obviously how high it is, but then I can see Y would be the bumping in and out of that, of those points. So coming from the side view, 1 3/8 is close, but one way to check this even better is I'll run you can actually see where that's kind of bumping in and out on those points. I'll run an inspection. So an inspection, what it's going to do is compare, let me turn the model back on, the scan data to obviously that flat plane I aligned it to down here, and colorize those point clouds for the distance away from any model component. So if I have a vertical surface, I don't even need one of the model of the stairway. But if I have just a vertical plane, I can do this. So I'm going to change this so it's a little bit clearer. But what you're seeing here is we got about a 1/2 inch, 1.5 inch. Green would be where we aligned it. That orange is kind of where it's leaning in from that alignment. But you can see that is showing me it's pretty good going across. Obviously, this wall is going to be pretty far off because of the alignment there at the bottom being a little bit wider. But if I just focus on this back wall, I can see I got about 1.5 inches to potentially, this may need to be grind down because obviously that yellow means it's about a 1/2 inch in. But really, because they're still building this and this is under 80 feet, I'd probably be all right with it. But I could communicate this by, from FieldLink, just exporting this cloud as an LAS or E57. That will bring this cloud in these colors. So I probably take the cloud and a couple images here so I can keep this scale bar with it. and share that with others on the team if there was an issue or if we did need to define where we need to grind down. If I needed to, I could actually create points here and start to essentially click on the scan points to create layout points if I needed to define where I wanted to start grinding. That's your in-field analysis. Obviously, we have the ability to measure and then run the inspection on that back wall. Moving over, I would share that inspection cloud, those measurements and images. I could also just share the entire cloud. Generally, I'd probably want to actually send more of this data, so not just the back wall, but bring in the floor and the opening, or to the opening. I can export this as an RCP non-structured or RCP structured if I'm going to Recap or Autodesk or Revit or Navisworks. And if I'm going to Realworks, I'd probably send a TDX or TZF. And you can see those other scans are aligned. But once I export that, I can come in to Realworks. So we'll be about 15 minutes in, we'll be switching over to Realworks to show you a couple of the deliverables you can create there, and then we'll be linking to a couple more videos as well too. So importing into Realworks, again, grab the TDX or import this TZS just from where it was saved. If that's on the, if I did this on obviously on the tablet and that's where they are, I would just bring a thumb drive over. At TDX or TZF, you can just write directly to a thumb drive and then find them and import them. Just select it, open it, and then sample by step and bring them all in. They should be aligned. Here is where in the registration screen, I would definitely still check the registration, make sure everything's going in well. So create a couple section boxes, and I probably want to refine too, but I can see here that each floor is tying together nicely. So that is where the registration check is, closing that and running the same refinement. I should get actually the same values because I've already refined in FieldLink, but I could rerun that here again to check it. So wrong scans, actually. This is I believe the ones we're looking at. Moving on to the production screen and the deliverables you can create. So once you have the cloud in, it's going to send everything. I'm just going to want to analyze the back portion. So what I'll do is I'll segment down just by clicking that and essentially look at just the back wall I want. So this would be the south wall of that. So here I could come in and do, again, a little bit more precise measurements as well too. And I only say precise because I can really see where I'm clicking to do this analysis, where I'm seeing like a delta Y, actually quite a bit less. So when we do our other analysis, we'll actually see that, or 0.16 of a foot is actually close to 2 inches. So relatively about the same what we saw in FieldLink. So a couple of, and we'll link to another video by Jason Hayes on how to do this one. But moving into the inspection workflow, I can select the cloud, and I've done this before, but we'll do it again. I can do a wall verticality inspection. So selecting the cloud and then selecting the wall verticality inspection is going to open that toolbox. And I can actually just go straight into that and start segmenting down. I can fit a vertical plane to the current cloud, which will, if I clip out the wall side, should be pretty good. And I'm just looking from the top to make sure, see what other junk we may or may not have in there. So it looks like we have a little bit too much. So what I'll do is actually segment down a little bit more, so I'm only looking at that wall. And we'll clean it up. So now when I do a vertical analysis, it'll just clip to that. Go from the top wall one more time. Yeah, that's looking good. I'm just looking to make sure I didn't include any of the other sidewall there. Oop. Control Z, didn't want to do that. Clip that stuff out. Over here as well too. Well, maybe I did include too much of that, so we'll we'll do a top-down view, and we'll do inside view or an outline. Got some junk there, so we're going to try and get rid of that. And moving on. Side view. Actually, we'll do it from the straight on. And once I'm happy with that, close the tool and define vertical plane to the current point cloud or segment part of it, which is generally what I would say to do, because then I know I'm going from create that vertical plane just from near the base, or what I would assume is the reference area of what I'm going up from. So right here. Actually, you know what? Just in case there's a little more spray off from that paddle, we'll do it just above there. So we define that plane for that small section, and then we'll actually do the analysis running all the way up to the entire core. So I got my positioning, vertical plane running up, and then a grid spacing of 3 feet. Anything outside of a half an inch is going to be out of tolerance, but I can actually run the inspection here to preview it. And so it's going to run that analysis, turn off some of these. But you can actually see where, again, at the top it was leaning over closer to an inch. At the bottom, I'd call it just fluff. So I wouldn't actually really pay too much attention. If that needs to be handled, it can be easily grinded because there's no fall or safety issues there. But this is going to create a couple of deliverables. So we'll call this the south side that we can then jump into. So here's my general analysis of what's in and out. If I really wanted to, I'd probably, we'll call this 1.6 would be 2 inches, and would really tell me if there's something I really need to pay attention to. But we're good there. If I go back to just 1 inch, 0.08, it'll probably tell me the top is leaning in a little bit over an inch, but obviously I get the plus and minus. So if I were to find that back, I could actually still stay within 2 inches there. We'll stay with our half-inch analysis and then show you some of the other deliverables just to make sure that you can see what's happening there. So we'll create that, close that. The deliverables made just from that are going to be like this really nice JPEG image. We can actually zoom in and see the deviation from 0.08 would be like an inch away or an inch leaning in from the plane that was created from the section down here. So you can get that inspection report. What you can also do is use the inspection map analyzer to create even more deliverables. So couple ones people like are like the section and shifts, where here it says actually I can create multi-slices of an interval every, say, 2 feet. And what that'll do is run the same analysis, but then show me here a green line showing where the points actually are versus the red line of that plane. And if we look at here, these are kind of what all those points will look like. So I can create all those, both lines, the reference line and the other line, as well as get this section plot and export those. We'll link to a good video showing that in the comments down below. but as you move through here, you can actually start to see where it starts to lean in and change throughout that a little slightly differently. The other thing a lot of people like is if I go to ISO curves, it will create me contours that can also be created with an interval of a 1/4 inch moving up. So you can really start to see where things are going poorly. Export both those as a DXF and bring them into Navisworks, Revit, or CAD. Obviously, you need to import them with the correct units, but they'll pop in the right spot. So those are a lot of the inspection you can do there with the map analyzer. Moving back, let's go here and turn this guy on, turn that off, and this is a walled section. You can also do a scan to model inspection, which you can run a similar inspection that you would get in FieldLink that you saw. Go 0.5, so it's a little more precise. We can create that same color eye colorization change with the tool, where you're seeing in and out of that with the same scale bar. So you can run the scan to model inspection. You can actually bring the model into Realworks as well too, and do a scan to model inspection as well too. So those are a couple of the inspections you can do. Moving into the modeling portion. So what I'll model here, I can just do I can mesh this and essentially let that live as the as-built if I wanted to really display what was there by going to surfaces and creating a mesh, which we'll do. And what that'll do is essentially convert the point cloud to geometry. So it's kind of downsampling it, but a better representation than just a vertical flat plane. So no projection, lightweight mesh. Again, I probably should have reduced the number of points or downsampled it, because that is probably overkill. So reducing the number of points here, you can see the mesh that is created from that scan data, which is going to be able to be created and actually exported as an IFC, really representing what it is. So I can clean this up and add into it too. Some of the other modeling tools that would be good to show you are like, we have some embeds here that we probably want to know their precise location. To do that, generally what I would do is segment. We'll look at one with I'd say a good, let's go with intensity. A good field of view, clean up around it, download that, and then start to model with the cloud-based modeler. So here, I'd select that cloud. I can go into modeling, cloud-based modeler, and assume that this is going to fit pretty well. So we'll do an extrusion. Actually, just a plane-based one, and fit to it. So you can see that'll actually create a kind of embed location on that wall, a model that, as I zoom out, when I close this one, you can actually see where it's going to fit. So let's see, there it is. I'll go through and actually do the rest of these, and I'll have a very precise model component that can be essentially designed to. With this, you could copy it, and then if I wanted to keep them all the same size, which I assume those embeds would be, and then I'd also run an inspection to fit it too. So I can move this one over. And here you can see the rest of those embeds modeled. Then what I could do is export them as a IFC. I'll export the actual section lines here, so we can run that comparison, and the ISOs, and bring them over to like Revit or Navisworks. So here you can actually see what it looks like. I'll use a section box. I did actually, to make my life a little bit easier, put in a local coordinate system. So this is obviously the model is in state plane. I just actually made a local one to have it fit in the view there. But within here, I can look and start designing to those embeds that I've designed there. I can see the other ones as well too. Let me see, insert, manage links. I can turn off this core, leave, unload, and then have my other DWG CAD formats. We're going to unload this. And then here you can see those embeds, the contour lines of that core going up, and I can start designing to that. So those are the various deliverables you can create. Moving back to Realworks, I can run an inspection, which I've actually already done here. Color, let's turn off some of these other ones. So what essentially this is showing me, is where it was, scanned a model inspection where I can actually see the deviation, kind of colorize those point clouds, just like we did in FieldLink. I can export this as an E57. I will need to open it up in Recap to actually make an RCP file to open up in Revit. I will also send over this full point cloud. And then to bring those open, I would simply merge that. Let me open Revit back up. I can bring those point clouds in. So here's the local kind of comparison there with the contour mapping going there too, which is nice, as well as the elevator wall, which should also pop in the right spot. So keeping those in the same coordinate system that we set in FieldLink will allow it to pop open in that model. Again, just for this one will be local. But those are a lot of the deliverables you can create and share. If you have any questions, please reach out to your nearest building point representative to get a demo on this. Collection is generally the longer part of this. You can generally go back in the office and recreate some deliverables and make sure your registration is going well. Again, to be within ACI tolerance, you're going to want to actually talk to your structural engineer, make sure where you're going at, and you may need to actually tie into some more control or have some control points within those scans as well too. Thanks, and this was a long one, but hopefully some of you will get through it and get some benefits on using scanning to confirm that what you're building is going in as planned.